In this video, we're going to look at testing hypothesis for mean when population standard deviation is unknown. So it's not provided within the problem. Okay. So all the components hypothesis testing is very similar, but for test statistic, we have to use t. And finding p-value is also a little different using a t-table. So let's look at it in detail. So for test statistic, this is when testing mean and we do not know the population standard deviation. So we don't know the population standard deviation. So then we use this t-distribution formula. And from the formula sheet, it is this one right here. We're testing for mean, population mean. We have two choices. In this case, we're looking at when population standard deviation is unknown. We use this formula to find test statistic. So test statistics is always either z or t for us. And depending on population standard deviation, known, unknown, it will be either z or t. So in this case, it will be t. So also in this formula, we're using sample standard deviation instead of population standard deviation. This is we don't know the population standard deviation. Okay, and we'll see to find the p-value, but the way we find p-value is a little different for t-distribution. We can only find an estimate of p-value using t-distribution table. So let's do an examples of how to find the p-value once we find the test statistic value. Okay, so let's look at this example. Find the p-value if test statistic is 2.940 for a left tail test with sample size of 61. So we always find the degrees of freedom, which is 61 minus 1 is 60. So we look at this value 60 and also t value of 2.940. Okay, so let's keep these two values in mind. And I'm going to go to the t table. Here's t table. Since this problem is saying left tail, that's we can read the one tail area. So we're looking at this row right here. Okay, and degrees freedom was 60. So I go down to 60. And from here, what I find is I find the two numbers that are smaller than 2.94 and greater than 2.94. So if I go down here, 2.94 is between these two numbers, 2.660 and 3.460. 2.9 is between somewhere here. But then we go up to see what are the p-value for each of these numbers. So for 2.66, the p-value is 0.05. Sorry, 0.05. And for, let me go that again, for 60, for 3.46, the p-value was 0.0005. So that means the test statistic of 2.94 must be between these two values, p-value. So we can estimate that for our problem, p-value is between 0.005 and 0.0005. So let me write that here. The p-value is somewhere between 0.0005 and 0.005. So we get a range for the p number for t-test statistic problems using t-table, t-distribution table. Okay, so let's look at two more examples. Let's say the p-value, t-test statistic for this problem was 2.108 and find the p-value for two-tail test with n equals 21. So let's find the degrees of freedom first. It gives us 20. And t-value we're looking at, the t-test statistic value is 2.108. Okay, so let's go to the t-table again. Here is two-tail. Two-tail means different than, right? So either one's fine. Either is either less than or greater than, right? So we're looking at two-tail. So we're looking at this row. These are the corresponding p-value. So 2.108 most likely would not be on exact values, not on the t-table. So we need to find the range which this belongs. So degrees of freedom is 20 right here, all the way bottom. Look at right here, 20 right here. And I go here until I find one value less than 2.1, greater than 2.1. So 2.108 is between these two numbers, 2.086 and 2.528. So 2.1 is between these two values. So I find the corresponding p-value for this one and this one. And then the p-value for 2.1 must be between these two values. So 2.086, the p-value is 0.05 because we're looking at two-tail. And for the number 2.528, the p-value is 2.02. So p-value for 2.108 must be between these two p-values. Okay, so let me write that. For this one, p-value is between 0.020 and 0.050. Okay, so we get a range of p number. We don't know the exact p-value from the t-table, but we can know the range where it belongs. Okay. So third one, it says find the p-value for t equals negative 1.108 from two-tail test. Well, or let's find the degrees of freedom. 20 again. And here is negative. For negative, we can actually take the absolute value for t values. Purpose of finding p-value using t-table, because there's symmetry. The t-table is symmetric. So we can use positive value to find the p-value. Okay. So let's go to the table. Okay, I actually like you to try. Why don't you pause the video and try to find the p-value range for degrees of freedom 20 of this value for two-tail test. Okay, so pause the video and try now. Okay, so let me go over it. Degrees of freedom 20, so we're looking at here. Well, it's also two-tail, so we're looking at these numbers here. So 1.108 most likely will be not exactly on the t-table. So what we do is we find the range. Well, 1.108 is between these two numbers, because this one's smaller than, this was greater than 1.108. So 1.108 is between these two values. So then I go up, corresponding p-value for this one is 0.5. Corresponding p-value for 1.185 is 0.25. That means p-value for this test statistic, 1.108, must be between these two p-values, 0.5 and 0.25 for two-tail area. Okay, so let me write that. P-value is between 0.25 and 0.5 for this problem. So we get a range. So this is what we mean by we can only find an estimate. We can only find the estimate as a range using a t-table. But this one affects the way we make the conclusion, because in the end, we're comparing p with the alpha. Okay, so as long as p is less than alpha, we can make the correct conclusion, at least the conclusion that we desire. Okay. So let's look at a full problem. Drug 6-MP is used to treat leukemia. The following data represents remission times in weeks for a random sample of 21 patients, and equals 21 using this drug. So from this data, we get sample mean X bar of 17.1, sample standard deviation of 10. So that's lowercase s. Let X be a random variable representing remission time for a patient using 6-MP. Assume the X distribution is mound shape and symmetry, so it's normal. Previous used drug treatment had mean remission of population mean of 12.5 weeks. Do this data, I'm talking about this sample data, indicate that the mean remission time using this drug is different, either way, less or more, from 12.5 weeks. So let's use the alpha 0.01. So let's set up the hypothesis statements. So what we're wondering is the mean remission time is actually using the drug 6-AMP is actually different from 12.5 weeks. Does this data right here indicate that the mean remission time using this drug is actually different from 12.5? That's what we want to test. So that's the alternative. And this tells us this is two-tail test. So the new hypothesis is equals 12.5 weeks. So let's find a test statistic. Test that is always either Z or T. In this case, it's T because population standard deviation is unknown in the problem. This is very important that we use T. So the formula for T is this. Well, sample mean, again, be careful when you both are mean. One is sample mean, one is population mean. So make sure you input the correct value here. Sample mean from this data was 17.1. So 17.1 weeks. Minus population mean was 12.5. Divided by sample standard deviation was 10 right here. Divide by sample size 21. Sorry, I meant right 21 for sample size, not 11. So this gives us 2.10798. Okay. Or let's run to 4 decimals. So it's just 80. So this is all we get for t value, t test statistic. So then for 3, we have to find p-value. We have to find p-value, third step. Well, we know that t is this value. And degrees of freedom, sample size was 21. So 21 minus 1 gives us 20. And it's also two-tail because it's different from two-tail. So we need to keep in mind all these 3 things when finding p-value using t-table. So let's go to t-table. Yeah, we're looking at 20. Let me go up here. 20 right here. And two-tail area, so we're looking at this row. So the t-value was 2.1, 2.108, 2.1. Let's find it here. 2.1 must be between these two numbers. 2.1 is bigger than this one. 2.1 is smaller than this one. So find the corresponding p-value for each of these numbers. 2.086 right here has p-value of 0.05 for two-tail. And p-value for 2.528 has two-tail p-value of 0.02. 0.02. So our p-value must be between these two range. So let's write that. Our p-value is between 0.02 and 0.05. And we can also say this is between, and it's excluding these two numbers. So p is strictly greater than 0.05, less than 0.02. You cannot equal to 0.05 because if it were to equal to 0.05, then the t-value would have been this one right here. Or excuse me, this one. If p-value was exactly 0.02, then t test statistic has to be 2.5, which we don't have either of exact these numbers. So that's how we know it's between these two numbers, excluding 0.05, excluding 0.02. Okay? So we found the p-value in the range. So then 4 is conclusion. We're asking, is p-value less than alpha? Well, alpha in our problem was, for this problem, was 0.01. Okay. So we know that our p-value is between these two numbers in this range. Whatever the p-value is, it is greater than. Oops, hold on, I messed up the numbers here. I meant to write 0.02. Let me fix it. Here I meant to write 0.02 and 0.05. I wrote it backward, right? Smaller, greater. So whatever p-value we pick here, whatever p-value is, actual p-value is always greater than 0.02. And 0.02 is greater than 0.01, which is alpha given in this problem, right? Because p is always greater than 0.02, according to our test statistic and t-table. Therefore, p is greater than alpha in this problem. Alpha equals 0.01 for this problem. Okay. So although we only have p-value as estimate between range, it doesn't affect us making a conclusion. You can also pick a random p-value to compare to alpha. Whatever p-value you pick between 0.02 and 0.05, that number is always greater than 0.01. Okay? So our answers to question, is p less than alpha? No, in our problem, which means we fail to reject. So for our conclusion, we fail to reject or do not reject. Means the same thing. Fail to reject H naught. So what does that mean? Let me write the conclusion in a sentence. Since it's failed to reject, there is not sufficient evidence to support that the drug 6-MP provides average remission time different than 12.5 weeks. So essentially, there is not enough evidence to support new hypothesis. Excuse me, alternative hypothesis. There is not evidence to support alternative hypothesis. So let's look at another example. Pyramid Lake in, I'll say this word, Patu Indian Reservation in Nevada. Suppose a friend tells you that the average length of trout caught in Pyramid Lake is 19 inches. However, the Krill survey reported that random sample of 55 fish. So that's the sample size 55. The mean length is 18.5. So here, this mean is referring to from sample. So this tells us that sample mean was 18.5 and the estimate standard deviation of 3.25. So this standard deviation is sample standard deviation. From the sample of 55, we got standard deviation of 3.2. Do these data indicate the average length of trout caught in Pyramid Lake is less than 19 inches? Use level of significance alpha 0.1. So here we're dealing with the mean, right? So let's write the hypothesis statements first. Here, this is the alternative hypothesis. Is the mean length less than 19? So it's left tail. Or again, left tail is also one tail. Right? Left tail is only one side, right? So null hypothesis then will be greater than equal to 19, or we can also write equal to 19. So here in this problem, again, we have to be careful. The population standard deviation is not given. That's why we use T for test statistic. So for test stat, we use T. That's very important because once we find the test statistic, the way we find the p-value is different from T and Z. So formula for T is sample mean minus population mean divided by sample standard deviation divided by square root of n. Sample mean was 18.5. That's the sample length, the mean of the sample 55 fish, the length. Minus population length, they claim that it's 19 inch. Sample standard deviation 3.2 divided by square root of sample size was 55. So this gives me negative 1.159 for test statistic. So remember, this is T. Okay. So let's find the p-value. P-value. Well, T is negative 1.159. But for negative, we can look at positive when we use t-table. Look at positive 1.59. And degrees of freedom is 54. Let me actually write it 55 minus 1. gives us 54. So when we find the p-value, we have to pay attention to this value, and also this is one tail. Since it's the left tail, one tail. So let's look at the t-table. 54, 1.59. 54 is not here, so we look at the smaller one, 50. And we also look at one tail, so we're looking at this row. So let's start from the left, right here, and find the value less than 1.59 and greater than 1.59. So 1.59, I'm sorry, 1.159. So 1.5, so this is greater than 1.5. This is less than 1.5, right? So these are the two values. So we found a p-value for this one, p-value for this one, and those are the range that our t-test statistic is in, right? So because 1.15 is in between these two numbers. So for this one, p-value is 0.25, and for the next one, it was 0.125. So our p-value is in this range. So let me write that down. Our p-value is between 0.125 and 0.250. Or we can write it like this way. P-value is greater than 125, less than 250. That's our p-value. So let's try to come up with the conclusion. Is p less than alpha? For alpha, or our problem was 0.1. Okay. Well, p is greater than 0.125, so it must be greater than 0.12, right? So p is actually greater than alpha. So no, we fail to reject. Fail to reject. H naught. We fail to reject. So let me write the final answer, final conclusion in a sentence in this context. There is not sufficient, since we failed to reject, sufficient evidence to support that the average length of the trout caught is less than 19 inches, which is, this is new, keep saying new, is alternative hypothesis. This is alternative hypothesis in words, right? So again, when you compare p and alpha value, be careful. P is in this range. P is greater than 1.25 though. It cannot be equal to 0.25. If p were to equal to 0.25, then our t-test statistic, where is it, 50, had to be this one, 0.679. Because we used 54 wasn't there, so we used a smaller one closest to. But our t is not this. So t is greater than, right? So hypothetically, right? Let's say hypothetically, alpha given in the problem was 0.125. Even then, our p is still greater than alpha, right? When we compare, is p less than alpha? Well, no, because our p is bigger than 0.125. So even if alpha was 0.125, we know that p is greater than 0.25. Okay. So keep that in mind. For t-test statistic, p-value is in a range using t-table. And let me go back to the formula sheet. What we looked at was this portion right here in this video.